analysis of the point clouds generated from UAV image data and terrestrial laser scanning for modeling information about historic buildings. The aim of the research was to compare the data obtained from the UAV and terrestrial laser scanning data. Points clouds were generated on the basis of the UAV image data and acquired with the far-focus scanner. UAV data were acquired at different flight altitudes and generated using different parameters. TLS point clouds were compared with UAV clouds for data completeness. The facility where the research was conducted is located in Warsaw, in the Warsaw-Wilanów district. The purpose of the measurement is the digital reconstruction of the object, which can be the basis for creating a scan-to-BIM 3D model for the needs of historic BIM. An UAV produced by DJI company were used to perform the flight. Image data was obtained from 3 heights, 40, 60, and 90 meters, to check whether the flight height will affect the quality of the generated point clouds. In order to obtain a better accuracy of the determination of measurement network points, a second GPS measurement was performed. The coordinates of the points were measured with an accuracy about 2 to 5 centimeters. The object was measured using far-focus terrestrial scanner. Over 7 million points were obtained, with an average resolution about 1.5 centimeters. For georeference, Leica GPS Viva was used. The points cloud from photos were developed in Agisoft Photoscan and Pix4D. Both use semi-global matching algorithm. Figure shows a summary of the generated point clouds for flights from different heights. This results in point clouds of varying accuracy and completeness. The comparative analysis were first performed from point clouds generated in various software. It was observed that the generated point clouds by Agisoft and Pix4D differently represent points on linear elements. The main difference between TLS point cloud and UAV in the mapping is the mapping of the roofs. The ground scanning maps the visible lower layers of the roof, while the image data obtained from the height map the top layer of the roofing. The differences in the generated cloud of the roof fragment can be seen in this figure on the left. In addition, the difference between point clouds obtained from TLS and UAV were compared by generating difference model in the cloud compare software. The red color on the models of differential point clouds on TLS and UAV are marked points that are more than 2 meters apart between these clouds. Another difference in the incompleteness of the point cloud with TLS resulting from the too close proximity of the scanning station to the object. An example of the incompleteness of the TLS and the example of the selected object is shown in the figure on the left. After preliminary visual analysis of point clouds, the best generated data for the later analysis were chosen. The measurement of the length of the characteristic elements of the object were calculated. The results of measurements of the length of linear elements are summarized in this table. As it can be seen, the highest value of the difference in length was obtained for the highest roof. In addition, the length of characteristic elements calculated on the basis of total station measurement data was compared with their equivalents on TLS and UAV point clouds. The difference can be seen in the table. The obtained values prove that the tested object was correctly mapped on the TLS and UAV clouds. The difference between these parameters is about 1 centimeter. The next stage of the analysis was to perform a comparative analysis of the coordinates of the characteristic points of the object. For this purpose, 20 points were selected on the object. As can be seen from the data in table, the comparison of the coordinates of the characteristic points between TLS and UAV clouds is subject to large error. The coordinates of the horizontal position are determined with accuracy about 11 centimeters and the height coordinates about almost 1 meter. On the basis of the conducted experiments, it was found that the modern UNV platform can be deliver geometric information about historic structures, of course, with limited accuracy. The geometric consistency of point cloud generated on the basis of low-cost UAV imagery is very high. Nevertheless, accuracy of the georeferencing is still a challenge for post-processing stage. Thank you for attention.